Okay, so safe harbor. You probably have this memorized by now, so you guys can read it again, and we'll get going. I'm Michael Halliday, and this is Liam Mediger. We work at Infotech Research Group. Liam is our Salesforce architect, and I'm the web Rails architect. Infotech is a research and advisory firm. Our head office is in London, Ontario, Canada. We also have an office in Toronto. We use Salesforce as our CRM, and we have a Ruby on Rails website that we sell memberships for, that allows our clients access to our best practice research, access to our analyst tools and templates, benchmarking tools, and we also do workshops to help improve IT operations. So, session overview, we're going to basically talk about the Infotech messaging system, so how we've integrated with Salesforce.com and our Ruby on Rails website. Liam's going to start and kind of go through the history of our first couple implementations, and then I'm going to tell you about our current implementation, which we've actually extracted out into a Ruby gem and open sourced it. So I'll turn it over to Liam. And
thanks, Mike. So as Mike said, we have two main systems at Infotech. We have Salesforce as our CRM, and then we have a Ruby on Rails site serving content. Within Salesforce, we use a bunch of the standard objects, such as contacts and accounts, and then we also have a series of custom objects to represent kind of how we run our business. So we represent subscriptions and memberships. All of this data we then need to sync over onto our website so that once somebody has been put onto a subscription, when they log into our site, they have access to the appropriate content. So in the beginning, we had these two systems. They had no way of talking to each other. So what we did initially was we built a piece of .NET code which sat in the middle to kind of broker messages between the two. So this implementation did two things. One, it sent messages, just XML, through to our website, which our site processed. And then when data on the website changed, it would send XML back onto a web service on this in this .NET app, which it then pushed to and from the Salesforce SOAP API. In order to track record changes, we built some custom revision log objects within Salesforce, which we populated through triggers. When data changed, we would sort of increment revision numbers, and then this piece of .NET code would pull these objects looking for changes. When it found them, it would suck that data out, it would push it up to the website. So we had something that looked like this little bit of .NET code in the middle on with some timers, running queries, listening for data and pushing it back out. And then we also did something like this. At some point we changed how we sold our memberships. We added tiered memberships, and in order to accommodate this, we did a bunch of translations. So we ended up with business logic in this integration piece, translating between the products that we were selling at a Salesforce and what our website knew about how to provide content access. So how did we get here? In 2009, we were mainly a .NET shop. We had a .NET website. We had an internally hosted CRM. In late October of 2009, we launched our Rails website. And it ran for a while. And then in August of 2010, kind of all on the same day, we did a few things. We switched over to Salesforce as our CRM. We also changed how we sold our memberships, and we changed how we granted access to our content on our site. So we ended up creating kind of a bandage. This whole system, it worked, but it wasn't ideal. We didn't love it, and we knew we were going to have to replace it at some point, but it was getting the job done. So we kind of took a look at what we'd implemented, and we came up with some of these pain points that we had. It was overly complex. The implementation was complicated. With all that business logic in the middle, it was hard to debug issues when they came up. You couldn't just look in one place. You had to look in Salesforce, in the web, and then at what happened in the middle and try to figure out what was going on. It wasn't very extensible just because of the way it was implemented. We were stuck maintaining an extra set of Windows servers off in the cloud to host this .NET service. It wasn't very efficient, and we actually got a few calls from Salesforce because of our polling mechanism saying, hey, why are you guys running queries so frequently? Because some of them were a bit slow. And it also ended up, we had a single point of failure. If this machine ever went down or anything, we were going to have some issues and be scrambling to fix them. So it was kind of like this old and rickety bridge. It got the job done, but the longer it was in place, the fewer people actually wanted to fix it. And this bridge actually, we had to drive over this thing in London up until a couple months ago. So at this point, we kind of sat down and said, we need to take a look at our overall implementation. You know, why do we have this? If we were going to start from scratch, what would we do and how would we implement it? So what we came up with was we kind of took a look at two technologies, and this was a little bit after Dreamforce last year when the databasedotcom gem was announced. We decided on databasedotcom in combination with outbound messaging. So I don't know how many of you guys have ever used outbound messaging before, but it's a feature of Salesforce which, through configuration, allows you to send SOAP messages out to an external system. So you just drag and drop, you can decide, you can add fields that will send data from records out into an external system. And we've combined this with workflow so that whenever data changes on records that we care about, outbound messages are going to go out to our website, which we can consume. One of the nice features of outbound messaging is that it provides some redundancy and queuing. So Salesforce will actually queue all these messages. It'll package them up into batches, and if it fails to deliver any of them, it's going to bring them back, it's going to re-queue them for up to 24 hours, so you don't have to worry about if your site's down temporarily or whatever, it's going to handle that for you. And we just built a quick, simple SOAP decoder on the website to parse these messages out. So we implemented this kind of as a proof of concept, database.com one direction, outbound messaging in the other direction, alongside our existing main integration solution. So at this point, we had a few new objects that we needed to replicate, so we kind of attached it on the side, had it running as a proof of concept, and it worked. It was good. It was working. It was a little nicer in that we knew exactly where this code was. We didn't have a middle service, but the implementation that we actually had wasn't ideal. We kind of realized that we had a lot of duplicated code. We were copying and pasting a lot of stuff. We ended up having to create one new class for every object that we wanted to replicate. So, not great, but we've proven that this kind of overall methodology was going to work. So at this point, we kind of took one more step back and did a full rethink about how we implemented it. And Mike's going to tell you a bit about how that whole process went and then what we ended up with.
Yeah, so we got a bunch of smart people in a room. It was the basement. We locked ourselves away with a whiteboard and no distractions, and I think there was a laptop involved. And we basically asked ourselves, how would we do this in an ideal way? We knew we wanted to get rid of .NET, that piece in the middle, and we knew we wanted to leverage database.com gem. So we got our list, and we basically knew we wanted to create a simple solution, keep the business logic where it belongs. And we wanted to be very extensible, and we really wanted to focus on configuration only. We didn't want to write a lot of code every time we wanted to sync a different object or different attributes back and forth. We wanted to leverage our Ruby on Rails expertise that we had gained over the years. We wanted to get rid of the polling mechanism and push data when it changed to the right spot, and which would make Salesforce.com happy with us again. And we wanted a reliable, solid, redundant solution. So basically, it was the power of quad programming. Since pair programming was good, we thought, why not add two more? And we really wanted to make a generic solution. So we wanted to keep all of our, we didn't want to make another black box, because we're really good at those. So we knew we wanted to eventually open source this solution. So that, so it forced us to keep our business logic out of the syncing mechanism. And we said to ourselves, if we can get our most complex object to sync, which in our case is our user model, on the web, because it syncs to either a contact or a lead in Salesforce, depending on its state, we could get all the other objects syncing easily. So basically, what we had to support was, for our user model, we had to support asynchronous syncing of attributes. So every time a user logs onto our system, we have to get that last login date over to Salesforce, and we didn't want to block the user every time they log in while we make that call. So we had to be able to spin these off in the background and sync asynchronously. We also wanted to optionally sync records on a per record basis. So not all objects are going to sync all the time. We also need to support one-way syncing of attributes. So sometimes we had to have attributes come from Salesforce to the web only, or the web to Salesforce. So we had to be able to handle that. And associations. So for instance, a user is associated with an account, so we had to be able to handle that on the Rails side as well. And in order to deal with record locking, we basically said for our client experience, the website's going to win. So if you're updating your first or last name on the web, and that's going to update the contact in Salesforce, that save is going to win. And but we only do send the fields that change to Salesforce. So if you just change your first name or last name, those are the only fields that are going to go over. And we basically started with our class, and we just basically drew on the whiteboard how we basically defined the interface for what we would want to use. So in this example, we call a method Salesforce syncable, and we wanted to just pass it a bunch of, like a hash of attributes and to configure itself. So basically we got this proof of concept working in an afternoon. We basically built a new bridge. And it worked. It kind of surprised us all. So we got this in production for about 2 to 3 months before we extracted it out into a gem. And this is actually the new bridge that replaces that old rickety bridge. You don't even know you're on a bridge anymore when you're on this bridge. So we extracted all of this stuff out into a gem, which we've just open sourced this week actually. It's currently called the Salesforce AR Sync gem, and it's on GitHub. And it's basically a Rails engine, and it has all the controllers and routes for handling outbound messages. So I thought I'd just walk you through a brief example of how this gem works and how easy it is to set up syncing. So I don't know how many of you have used Rails in a couple people. So in your gem file, you just include Salesforce AR Sync, and you do bundle install, and then in your routes file, you simply mount the engine at a mount point. In this case, it's /integration. And as I said, we wanted to be configuration only as much as possible. So in Salesforce, as Liam was mentioning outbound messaging, so you'll define your outbound message for an object that you want to sync. In this example we're going to sync contact. So you define the attributes you want to sync on that contact. For deletes, outbound messages don't fire. Workflow rules don't fire when you delete an object in Salesforce, so you have to do a bit of Apex coding just to catch deletes, to send deletes over. But we have examples in our README on GitHub of how you do that. This is an example of the outbound message configuration screen. So your outbound message. So in Salesforce contact, you have in this example, the ID, the account ID, first and last name, and we're going to sync that to the contact record in Rails, which has a first and last name and account. So what we would do on the Rails side, we would basically call, on the contact active record model, Salesforce syncable. We basically just pass a hash of attribute mappings to the Salesforce attributes to the Rails attributes. So in this case, first name to first name, last name to last name. And account ID is an interesting one because it maps to Salesforce account ID, which is not actually an attribute on the contact, but what the code is going to do is it's going to look for a getter or setter method on the object in order to set that account. So here's an example of the Salesforce account ID setter method on top. The Salesforce account ID will be passed in, and then we basically have code there to look up a Rails account and associate that account based on the Salesforce account ID. And going back to Salesforce, the Salesforce account ID getter method basically just goes and grabs the Salesforce account ID off of the account model. So, and that is probably the most complex bit of code to get working, and it's not really that complex. So, under the covers, our gem basically handles all of the syncing using databasedotcom, and we think it's pretty cool. A few constraints. It does require Rails 3.1 or greater. It is a mountable Rails engine, so that's why we require Rails 3.1. And it's built into dependency for delayed job. I don't know if whoever's used delayed job here, but it's a kind of a background processing queue for Rails. So it is dependent on that. Again, deletes from Salesforce does require a little bit of Apex coding. The gem currently doesn't support contact and lead merges. We found that one difficult to make very generic because we have specific business rules in place. So we handle that separately. So the gem does not currently do that. And for the async attribute syncing, such as the last name or the last login date, you can't guarantee the order that those attributes go to Salesforce. So if you require that they go in a specific order, it's best not to use the async attribute syncing. We do have a sample app on the GitHub repository that has working code, and it is deployable to Heroku. Some future enhancements for this gem: we'd like to eliminate the dependency on delayed job and perhaps support other queuing mechanisms such as rescue. And again, better support for the asynchronous attributes and a better name. We kind of went around the office and we tried to come up with a good name, but nobody could think of one. So if you have any names, you can tweet with the hashtag SFARSync, SFARSync, and you can fork the code on GitHub and contribute to our new open source project. So that's it in a nutshell. You guys have any questions?